So let's color them in kind of bluish. Now, what's more important than the parallel lines are the transversals that cut them. So let's just highlight one of the lines. Let's highlight this line here. That is definitely a transversal going through parallel lines, right? So as soon as I see a transversal through parallel lines, more often than not, I'm just looking for alternate interior angles. We might look for corresponding angles or same side, but the first thing I'm going to look for are alternate interior angles. And the first one I see is this 47 and this 3. This 47 and this 3 are alternate interior angles. And if you remember, alternate interior angles must be congruent. So if those are alternate interior angles, that makes 3 47 degrees. Now, where people are going to mess up is they're going to tell me that 5 and 4 are alternate interior angles. They are not. Look at what I've highlighted. This whole thing and this whole thing would be alternate interior angles. My advice to you is stay away from complex alternate interior angles. Look for the ones that are just like super easy. You can see the angles are formed by the transversal in there. All right, so I'm just going to use that one for right now. Let me erase this yellow, red roof colors. Not easy today. All right, we have blue. We got blue. Let's highlight the other transversal, this one right here. And I'm going to go, okay, if this is 52, 2 must also be 52 because these are alternate interior angles. So this is also 52 degrees. You're actually done here. You're done here because maybe I'm putting you on the spot, but what do these two angles add up to if they make a straight line? 180. So I just need to do 180 minus 52, and I got angle 1. And then, Caroline, same thing's going to happen here, right? Because this plus this has to equal 180. 180 minus 47 is going to give me that. We got 2 ways I can get to this 5 here. One way is a straight line's 180, right? So if I do 180 minus 47 minus 52, that'll give me that 5 here. Or you could go, oh, this is a triangle where I know 2 angles. So I'm going to go 180 minus the 52 minus the 47. That's going to give me my 5 as well. Okay, is that good enough? All right, awesome. What else we got for questions? I do want to talk about like these. Oh, yeah. 12? 12, find the values of x and y in the diagram below. So the big thing we need to realize is we have vertical angles. Bless you. You can't do this problem without realizing that you have vertical angles. And vertical angles are congruent. If they're across from each other, they're the exact same size, which makes this one 6x minus 11. Which means I now have, notice that both of these are x's, and this one has x's and y's in it. So if I set up this equation, I have x's and y's in it. I'm going to stick to this one. This is going to be the first one I do. I'm going to say, okay, all of these angles must add up to 180 degrees. So I'm going to go ahead and go, okay, that must mean that 6x minus 11 plus that x plus 5 plus that 81 has to equal 180 degrees. Now I'm going to let you do kind of the algebra on it, but does that make sense how I came up with this equation? Yes. Okay, so we solved that. We end up with x equaling 15. Now what I would personally do, this is how I'd solve the rest of this. I would take that 15 degrees, I would throw it in for that x, I would throw it in for, oh, that's the only x I have. All right, so I'd throw it in that x, come up with the measure of this angle, and now I have this plus this equals 180. Is that, do you want to see that?
No.
You sure?
Yes.
Okay. Does that all make sense then?
Yes.
Okay, awesome. Other questions? All right, for 13, 14, 15, 16, the ones below it, a lot of us didn't, because I probably didn't put on the answer key, but I'd highly suggest you draw a picture, because I will grade your picture. If you get everything wrong, at the very least, I can grade your picture. So if it says there's a triangle MNP, I'm going to draw a triangle MNP. And I'm going to draw it the same way every single time. And this is going to be important today because we're going to talk about isosceles and equilateral triangles. It's going to be important for us to draw the drawings correctly. Now it says angle M is 4x minus 3. It says that N is 9x minus 6. And it tells us P is 6x minus 1. Now, did I ultimately need the drawing? Maybe not. Maybe I didn't, because I could just realize it's the three angles. Three angles add up to 180, so I might have just been able to come up with the equation. But when you're on a test or a quiz, like I said, I'll give you a point for having a correct drawing. Even if I don't ask for a drawing, I can still give you a point for the drawing, even if you have everything wrong. So I highly suggest you draw pictures. And once again, particularly today, because we're going to have what are called isosceles triangles, which we covered, and equilateral triangles. And it's going to be important for us to draw it correctly to know what's equal. All right, last chance for any questions? Oh, 16. 16 says JKL. Once again, we should draw the picture JKL. JKL. It says K is 9 more than angle J. Uh-oh. 9 more than angle J. So that's going to be important. Angle L is 21 less than angle J. We got 21 less than angle J. Find the measure of each angle. So the key to this one is, notice how they're both comparing to angle J. They said this one's 9 more than angle J. This one says it's 21 less than twice angle J. Well, I'm just going to make angle J K. I'm just going to say that's my unknown variable. So I'm going to make J. I'm just going to call that X. So if K is 9 more than angle J, I'm going to have X plus 9 for K. And if L is 21 less than J and J is X, or 21 less than twice J, so my L is going to be twice J, which would be 2X, and 21 less minus 21. And now I just need to do this plus this equals 180. Okay? So if I'm ever comparing anything to just one item, just call it X. It makes your life a little bit easier. It's your unknown angle. Okay? All right. Today we have two things we're going to talk about. And there are two things we've already talked about before. We're just going to talk about the importance of it. And in fact, the first one is probably the most important one that we pay attention to, because the second one's going to be a little bit easier. And that is isosceles and equilateral triangles. That's all we're going to use today. Just isosceles and equilateral triangles. Well, when we have an isosceles triangle, if we reach back for what an isosceles triangle is, to be an isosceles triangle, you just have to have two sides that are congruent. That's an isosceles triangle. It doesn't matter if it's obtuse, acute, right. It just says to be an isosceles triangle, you must have two sides that are the same length. Well, those two sides, those two congruent sides have a specific name for a triangle. We call them the legs of the triangle. So the two congruent sides are called legs. It's the legs of the triangle. The angles where the legs intersect is called the vertex angle. It is the vertex angle. And really, yeah, I mean, we got three vertices, but we call this one primarily the vertex angle. So which one of these is the vertex angle? Well, that would be angle 1, would be called the vertex. So we got a vertex, we have two legs. Then we have the side opposite the vertex, or the side that's not the legs. That is kind of unfortunately called the base. And why do I say it's unfortunate? It's because a lot of times in geometry, we think of things as being up, down, left, right, and that's important to us. But geometry has no real up, down, left, right. It's kind of like just if you go to space, there is no up or down. So a base is just referring to something that is across from a vertex. And why do I bring that up is because, let me draw a shape real quick for you. Ooh, got the alarm going. If I have this picture here, so when you think of base, a lot of times we think it's the bottom of the drawing. Well, in this case, the base would not be here. The base would be here. This would be my base. So the base just refers to the one that's across from the vertex. It can be any direction. Basically, it's the one that's connecting the two lines here. So with the base comes angles attached to the base. So we have a vertex and we have 2 and 3. Those are those angles attached to the base. Those are called base angles. So we have a vertex and we have 2 base angles. And realistically, today is a lesson just on base angles of an isosceles triangle because they're important to us. We have what's called the isosceles triangle theorem. The isosceles triangle theorem says if 2 sides of a triangle are congruent, so that means I have an isosceles triangle, then the angles opposite those sides are in fact congruent. So in this picture here, do you notice how we have an isosceles triangle with 2 equal sides? That means not only do we have 2 equal sides, we have 2 equal angles. So we would have angle 2 is congruent to angle 3. Basically, those angles that are across from those sides are going to be congruent. So the theorem says, hey, if you have an isosceles triangle, then your base angles are congruent. It says if you have an isosceles triangle, then your base angles are congruent. So if I want to do an example of this, I would say something like if the sides are equal. So if what is that, AB is congruent to, I guess, CB or BC, then the angles are congruent. Then angle A is congruent to angle C. So the theorem goes, if sides are equal, then angles are equal. I'm emphasizing that direction because look, we have one more thing called the converse. If you remember converse from that little section where we have like our hypothesis and conclusion, our converse is we just switch the hypothesis and conclusion. So if my theorem says the sides are equal, then the angles are congruent, then the converse must start with the angles. The converse says, hey, if you ever have a triangle where 2 angles are congruent, then the sides are also congruent. So that goes from angles to sides. So the converse is going to go, well, if I ever have 2 angles congruent, so if angle C is congruent to angle A, then the sides are congruent. Then AB, or, yep, I had AB, is congruent to BC. We're not going to have proofs in this chapter because we only have one more lesson after this. But I could ask you, would you use the theorem or would you use the converse? Just remember the theorem is you go from sides to angles. The converse would be angles to sides. All right, we're going to use this fact to solve more triangles. Just like we did before, we just have more facts in our pocket, more tools in our toolbox. So as a reminder, I did want to keep to this drawing. If I had these 2 things are congruent, that would mean that these 2 angles would be congruent. All right, it's not always just the bottom ones. It is the ones across from our sides. So the first example we have Okay, we have JKL. I'm supposed to find angle J. I'm supposed to find angle K. What's the measure of angle J? Yeah, what is it? It's 68 degrees. Do you guys see how we have two tick marks here? Those are congruent. If those are congruent, then the angles opposite them are also congruent. So that means J is going to be 68 degrees. And if we know two angles of a triangle, you know the third angle. Can someone raise your hand and walk me through? How do I get the third angle if I know two of them? Yeah, Caroline.
180 minus 68 minus 68.
Perfect. We just go in our calculator. We take out our calculator and go, oh, I'm going to go 180 minus 68 minus 68. That's the easiest way to plug in our calculator. And what does that come out to? What was that? 44? Can I get a second on 44? We're good with 44. Let's go 44 degrees. So once again, you just take this and it's just 180 minus 68 minus 68. Here's where we get a little bit of different problem. We are given the vertex this time. But you still have to recognize that your base angles are congruent. So that angle C and angle E are now congruent. How many degrees are inside of a triangle if I add up all the angles? 180. So what I'm going to do, I'm just going to take, well, we have that 106 there. I can't use those for either one of them. So I'm going to go 180 minus 106. And that should come out to what, 74? Does that mean each of the angles are 74 degrees? No. How did you find the angles?
Just divided 74 by 2.
You divided 74 by, because it has to equally split between those two, right? So we're going to take that 74, we're going to divide it between these two angles. So those two angles must be 74 divided by 2. Which should be 37 degrees. And if you're never sure about your work, just do 37 plus 37 plus 106, and it better come out to 180. Okay, our next one, it's asking for, do you see how it says YZ? We're no longer asking for a angle, we're asking for a length. We're looking for that length from Y to Z. We now have to use the converse. So the converse of the theorem says, if you ever have two angles that are congruent in a triangle, see how this is 77 and 77? Those are both congruent. That means the sides opposite those angles must also be congruent. So if that's 12 centimeters, then my YZ must also be 12 centimeters. And if I know two angles, I know that third angle. Can someone give me that third angle? What's the measure of that third angle? I heard a 26. Is it 26? Did anyone else get 26? Whew, this is going to be a long lesson. You got 26 over there? What do? We do 180 minus 77 minus 77, and we should get out 26. All right, the only difference between what we just did and these is we now have no numbers. We just have to understand what's congruent and what's not congruent. Remember with the full triangles, we had to figure out if it equaled 180 or if you had to put an equal sign because it had an exterior angle. So the only thing here is we have to recognize that I have an isosceles triangle, which means our base angles must be congruent. So that means that this is congruent to that. So I'm just going to slap an equal sign between those two things. So I'm now going to have 5x plus 9 equals that 8x minus 30. Remember, I put that line there because we have to keep the equal sign. We have to simplify either side, but there's nothing to simplify here and there's nothing to simplify here. So that means I need all of the x's on one side. I need all of the numbers on the other side. It is up to you. It doesn't matter which one you pick. Either you need to get rid of the 5x or you need to get rid of the 8x. I'm going to go ahead and I'll just get rid of the 8x because I think I did the other side before. So I'm going to subtract 8x so that's gone from that side. Now, what I do to one side, I must do to the other side. So I'm going to subtract 8x there. 5x minus 8x is a negative 3x plus 9. That 9 comes down. That negative 30 also comes down. And now I have all the x's on one side. Now we get all of the numbers on the other side. So that means I don't want this positive 9. What's the opposite of a positive 9? A subtraction, or a negative 9. So we're going to subtract 9, so that's gone. I subtract 9 from over here. I make sure I keep my equal sign. I know I have the line, but I want to keep that equal sign. That's gone, so I just have a negative 3x. I have negative 30 minus 9. Negative 30 minus 9 is a negative 39. Then to get rid of the thing right in front of the x, we're going to use division. Make sure you divide by a negative 3 so that I have a positive 1. Divide by a negative 3, and we just come up with x equals a positive 13. Okay, let's look at number 6. If base angles are congruent, what do we know about the sides across from them? If these base on number 6, so see how the angles are equal? What do we know about the other sides then? They're equal as well. So if my base angles are equal, then the sides across from them are also equal. So we can kind of draw this line and put a tick mark. Draw a line and put a tick mark. So that means we're going to have 15x plus 7 equals the 23 minus, I'm sorry, that's a 23x minus 17. I'm going to kind of quickly go through this one. Let's go ahead and move the 15 to the other side. So that means I'm going to subtract 15x from both sides. Carry down that 7. 23 minus 15 is going to give me 8x minus 17. To move this 17 to the other side, I must add 17 to both sides. Seven plus 17 is 24 equals 8x. To get rid of that 8 in front of it, I'm going to divide by 8 on both sides. 24 divided by 8 is going to be 3 equals x. Do the other two. Yeah. What was that? Mm-hmm. Yep, absolutely. You should get the exact same. So if you look at it now, you're going to have, I think we should have had a negative 8x though, because we had, because we're subtracting 23 from both sides, it looks like. So we would have subtracted 23 from both sides, not that 50. So do you see how you cross out the x's here? It looks like you moved this over there. So we actually subtracted 23 on both sides. Does that make sense? Okay. That's why he does a negative there.
I mean, but it could still be worked out like that.
It could absolutely work out that way. Yep. You actually have it. If you just continue it, you'll have this. That's okay. That's okay. As long as the setups are correct. As long as you know how to. Remember what I said? If we get to the test, make sure our setups are correct. Especially if we're running out of time, just make sure your setup is correct. So if I was on a test, I would go, okay, since I have congruent sides, that means the angles are congruent. So the setup that will get me a bunch of points in this problem is just putting 4x plus 7 equals 9x minus 33. For the next one, I might just skip down and go, okay, these two things are congruent. 74 is congruent to 74. So that means our sides must be congruent as well. So that means the setup for this one could be 9x minus 73 equals 3x plus 23. Now, because we know we're going to have a bunch of these problems kind of together, I have the big chunk of those points. If I'm not great at algebra, I'm just going to set them up, make sure they're 100% correct, and then use whatever remaining time I have to actually put the algebra in. Okay, so let's do the algebra real quick. We know we have to have the x's on one side. You get to pick whichever one you want. Either you're going to subtract 4x from both sides, or you're going to subtract 9x from both sides. It's up to you. You just have to go, which x's do I want to get rid of from the side? I'm going to go ahead, I'm going to subtract 9x from this side, which means I need to subtract 9x from this side. And now I have 4 minus 9, which will give me a negative 5. So we're going to have a negative 5x plus 7 equals a negative 33. Now I'm going to go ahead and I'm going to subtract 7 from both sides. That's going to give me, that's gone. I'm going to have that negative 5x is still there, equals a negative 40. Divide both sides by a negative 5 in this case. A negative by a negative is a positive. So we should have x equals a positive 8, the 8. Just for time-wise, I'm going to kind of fire through this last one. To move the x's to both sides, I'm going to subtract 3x from both sides. That 3x and negative 3x will cancel out. I'm going to now have 9x minus 3x, which gives me 7x. Minus 73 equals 23. I'm going to go ahead and I'm going to add 73 to both sides, so that negative 73 cancels out. I still have that 67 hanging out there. I still have my equal sign, but now we have 96. And now we're going to go ahead and we're going to divide by 6. And we should come up with x equals 16. Remember, a calculator helps out in a lot of this stuff. Just plugging things in. This class is not about how much math you could do in your head. It's about getting things correct. So if that means you need to plug in your calculator to get it correct, then plug it in a calculator and get it correct. All right, questions on any one of those? Okay. Then what adds to it are problems like this, where we have to draw the picture. We have to draw the picture. So they said there's some triangle RST. I am going to draw triangle RST. So I'm going to draw a triangle RST. It's important that we draw this picture because they're going to tell you what things are congruent, so you're going to be able to figure out what other things are congruent. So it's going to tell you RT is congruent to ST. So let's put our tick marks on there because they told me RT is congruent to ST. If those two sides are congruent, what two angles are congruent? S and R are congruent angles. So I could actually go ahead and put that on there. I could put, you know what? I know that these two things are congruent because that's going to be important to this drawing. Now, if you don't draw this picture or you don't pay attention to it or we're just goofing off, we might just put R and T are congruent to each other because we just look at it as the base because that's how we drew it. But you need to realize it's the angles opposite the sides are congruent. So then they go, oh, R is 9x plus 2. Then they tell you S is 13x minus 18. And then finally they tell you that T is 17x plus 1. Had we not drawn this picture, we might not know which two are congruent. But because we have these sides are congruent and these angles are congruent, this is our equation. Our equation is 9x plus 2 equals 13x minus 8. We're not using that 17x plus 1 to solve for anything. We know that these two things are congruent. Congruent means equal sign. So 9x plus 2 equals that 13x minus 18. Any questions on that logic? So I'm throwing a third one at you just so you can't just randomly pick two things to put an equal sign between. You need to look at what's congruent. And so we can go with that 9x plus 2 equals 13x minus 18. I'm going to save us just a little bit of time. Yeah.
We forget about this 18.
We forget about it right now. We're going to have to bring it back in because it does say find all of the angles. So once we solve for x, we need to plug it back in. But that's why we drew our picture to say we need to put an equal sign somewhere, right? So we're going to put our equal sign between those two. Let's pause right there. Let's pause right there. How many degrees are inside of a triangle? 180. Would it be possible to say this angle plus this angle plus this angle equals 180? And you'll come up with the exact same answer. This just can save you a little bit of time because you could just put one equal sign. It's a little bit easier than combining everything together. So you could have, on the test or quiz, if you said t plus s plus r equals 180 and you solved it correctly, you'll get the right answer and I won't take any points off. This just streamlines it a little bit because we can shortcut it to just that. All right, if we go ahead and solve for that, I'm just going to cheat real quick just so we have some more time. If you solve this correctly, you'll come up with x equals 5. So we have 5. Then we take these and plug them into each of these. All right, so to get r says r is 9 times something plus 2. Well, it's 9 times 5 plus 2. So this r right here comes from that 9x plus 2, but we're going to have 9. Instead of x, we'll go times 5 plus 2. Well, that's 45 plus 2, which would be 47. To get to s is going to be 13x minus 18. That'll be 13. Instead of x, we'll put a 5 plus 13. And then to get to t, we're going to do 17x plus 1, which would be 17 times 5 plus 1. Those should all come out to what? I already knew that. It should be 47 and 86. Did you hear me say I already knew S was 47? How did I already know S was 47 without doing any work? Yeah. They have to be congruent. So if I found R, S better be the exact same. Otherwise, I made a mistake somewhere in there. All right. I'm going to skip down to equilateral triangles. Equilateral triangles actually only have one important fact. Well, a couple important facts, but one we already know. If I say something's an equilateral triangle, what do you think of? Equal sides. You think equal sides. If I say equilateral, you should think equal sides. Now, when I brought up equilateral, I said all equilateral triangles are also equiangular. So equilateral, when you think equal sides, you should also think equal angles. So that's what this says. A triangle is equilateral if and only if it is equiangular. So as soon as I tell you it's equilateral, you should put tick marks on it. But you should also realize that all the angles are in fact congruent. Well, we can actually figure something out here. If all the angles of equilateral triangle are congruent, what do they all have to add up to? 180. So what does each measure have to be? It has to be the exact same, but when I add all three of them together, it has to equal 180. What does each angle have to measure? has to equal 180 divided by 3. 60 degrees. So as soon as I say equilateral, we should already know all sides are congruent. But what I want us to start thinking about, if I say equilateral, you need to think 60 degrees. Equilateral, 60 degrees. Because I told you that this is equilateral triangle, which means all of these are 60 degrees. That's more important than them being congruent, because now I actually have a number. So, real quick, this is the most important thing I want to take out of this. I'm going to put some other stuff down, but this is the most important thing we want to take out of this, 60 degrees, okay? So, equilateral, I want you to think 60 degrees. The other part is just, if you know all the angles are equal, then all of the sides are equal. So then kind of AB is equal to BC is equal to AC. And if all the sides are congruent, then all of the angles are congruent. So that means measure of angle A equals measure of angle B equals measure of angle C. Yeah, cool stuff. But that's not earth-shattering. The earth-shattering thing should be the 60 degrees. If I say you have an equilateral triangle or an equiangular triangle, you automatically have 60-degree angles. Okay. If you know two angles of a triangle, you know the third one, right? But more importantly, if both of them are 60, what does the third one have to be? Has to be 60. It's the only thing that works. All three of them are either 60, or you have only one of them that can be 60. So if you see a 60, you can do the 180 minus 60, but you should realize that, oh, this must be a 60, 60, 60 equiangular triangle where all the angles are equal. If all of the angles are equal, what does that mean about all the sides? They're also equal or congruent. Yeah. So we could put tick marks on all of these. And if one of them's 9 feet, that means all of them must be 9 feet. So BC must be 9 and AC must be 9 as well. This is where we have to know that 60 degrees because it can be easily forgotten. And you look on there and it says, oh, I have an equilateral triangle, but I need to find the angles. You either know how to do this problem or you don't know how to do this problem. Because there's no angle given to you. You need to realize that if there's a tick mark on all three of them, that means all three angles equal what measure? What was that? Oh, yeah, all the sides are 24. I love it. What would the angles be then? If all of them are 24, then all the angles are going to be 60 degrees. So all of these must be 60 degrees. Which brings us to a question like this one. PQR is an equilateral triangle. That means all of these sides are equal to each other. So if all the sides are equal to each other, that means we can pick any combination of the sides and put an equal sign between it. We could put 14y minus 59 equals 9y plus 1. We could put 14y minus 59 equals 11y minus 23. You could put 9y plus 1 equals 11y minus 23. That doesn't work for an isosceles triangle, but it works for a equilateral triangle. So you pick whatever one you want. I usually pick the ones with the smaller numbers. So maybe these two. Maybe I'll choose the 11y minus 23 equals the 9y plus 1. But once again, you can pick any combination you want. I'm going to pick this combination. Those two are equal to each other. So I'm going to go with 11y minus 23 equals 7x minus 3. No. Oof. Brain die for a second. I want to make it equal to 9y plus 1. There we go. All right, I need all the y's to one side. That means I need to either get rid of the 11y or I need to get rid of the 9y. I'm going to get rid of the 9y. So I'm going to go ahead, I'm going to subtract 9y from both sides. 11y minus 9y is 2y minus 23 equals the 9y minus 9y. That cancels out. That's why I always cross it out. Equals 1. How do I get rid of a negative 23? I add a 23. I add a 23 right below it. Because I want this to cross out, which means I need to add 23 to the other side, which will give me now 2y. Make sure you preserve your equal sign. A lot of us lose it for some reason. 23 plus 1 is 24. To get rid of a number in front of y, I'm going to divide by 2. And I come up with y equals 12. All right, y is easy enough. We could pick any combination as long as we put an equal sign between it. Now, the problem does not tell you what any of these angles equal on the surface, but it did tell you because it said it's an equilateral triangle. What's every measure of every equilateral triangle that's ever existed? 60 degrees. So that means this angle must be 60 degrees. They're all 60 degrees. So in this place, I'm going to go, oh, because it's equilateral, that must be 60 degrees. Which must mean that 7x minus 3, because it's occupying the same space as 60, must equal 60 degrees. So we're going to have 7x minus 3 equals that 60 degrees. Well, notice how we have just x's on one side already? Don't move your x's. We're going to get rid of that 3 first. The opposite of negative 3 is adding 3, so we're going to add 3 to both sides. That's going to leave me with 7x. The 3 and negative 3 cancel out. Equals 63. If you have a number in front of a variable, you divide to move it. Well, 63 divided by 7 is 9. We have x equals 9. Any questions on that?
You don't do anything with the 14y.
We did nothing with the 14. You could have, though. You could have used it. Remember I said we could have used any combination we wanted to? I just decided I didn't have to use it. Now, 13. Let's compare that to, I'm going to go back to a problem, okay? I want you to compare this to a different problem. Just remember, I could pick any combination I wanted to with the sides, right? Let's go back to, really quickly, we're just going to set it up. Let's go back to this one. This one is not an equilateral triangle. So once again, we should always draw a picture if one's not given to me. So they said that there's a triangle DEF. They tell you that D is congruent to E. And they tell you DE equals x plus 4. They tell you EF is 4x minus 8. And they also tell you that DF, did I miss something? EF is 4x minus 8. Oh, DF is 7x minus 35. Now, I told you to compare it to the last one, right? The last one, we could pick any combination we wanted to of those. Is this an equilateral triangle? Does it say all the angles are equal? No, it just tells you 2 are equal. And if only 2 are equal, that means it's an isosceles triangle. An isosceles triangle means that you're going to go across, put a tick mark, across, and put a tick mark. This x plus 4 is useless in solving this equation. The only equation you can write is 4x minus 8 equals 7x minus 35. So this is the only one you can write. 4x minus 8 equals 7x minus 35. That's the only one that will actually help you solve this. I'm not going to finish. I can put the answers down if you would like to try it, but you should come up with 9, 13, 28, and 28 if you do that one. But you got plenty of homework problems to practice that on. But I just want you to be very aware that draw a picture. If it's equilateral, all the sides are congruent. If it's isosceles, just 2 of them. You're going to need to figure out which ones to put the equal sign between.